Go backwards. Okay, submitting online. It really hasn't been. We talked about it really early in the first couple of weeks. Submitting online, and it really hasn't been an issue because we've been able to do this. But it's becoming an issue with our ever-changing CDC guidelines. And obviously, if you haven't been paying attention, there's been much more COVID cases here recently. So the probability or the possibility that you get either catch COVID or get close contact dinged is increasing. If you are at home, you need to stay up and if you're really sick, that's fine, you get the extra days. But if you're just at home because you're quarantined because you came into close contact, you need to stay up with your work. It's not like you come back after 4 days and say, what did I miss? We put all the assignments online. You need to do them each day and submit each day. Okay, so that is a case unless you are sick, like really sick, like if you're home puking and you can't do anything, we understand. But if you're just home chilling, you have to keep up with your work and submit it online. Okay, so by the end of the week, we need to have this where everybody can submit their homework online. They know how to do it, and you don't have issues with it. So like if you're out, you can keep up with your work. It's submitted online, and then you are up to date. So by the end of the week, now Gavin does it really well. He knows how to do it. Diana does it. If you know how to do it, then what I want you to do is you submit tonight's homework. And then if you don't know how to do it, what we need to do is we need to get that fixed. Okay, it's not that hard. And there's multiple people in the school in your grade that know how to do it, mentoring or whatever. Just you can ask for help. Who knows how to submit online? Put your hands up. All right, there we go. So we should be good. So from here, now, if you're here, it's not as big of a deal. It's when you're absent. You're at home, take a picture, load it through Canvas, so we get it. So, so you can stay up to date. So tonight's homework, submit it online. And so anybody that doesn't, then we can figure out if you're having an issue, how to fix it, okay? So that's going to be the same thing. We're going to submit online. All right, we skipped section 5.5. We're going to do, at this chapter, we're going to do 5.4, 5.6, and 5.7. And we're going to have kind of like a mini quiz on Friday. And we got to do two things on Friday. We're going to do this another quarterly checkpoint we did earlier in the year to kind of help get us ready for the state test. To kind of give you an idea of the format, some of the types of questions. It won't take all period. And then you're going to have like I said, a mini assessment. We haven't finalized exactly the point value yet, but it's not going to be like a 50-point quiz. It's more on the smaller side, but it will be a summative grade. It'll include these right here. No solutions infinite, which you did really well on. All right, the next part, graphing inequalities. So we're going to get to the graphing part in a second. The first thing you have to do is you have to tell whether something's a solution. So on those guided notes right there, you have an ordered pair. Without me telling you anything, is negative 2, 4 a solution to this inequality? Okay. Is that a solution to that inequality? Or you can even go further and say, this is how you would tell. Okay. So, $1,000 question. You got $1,000 on the line. Mr. Parker's ready to hand it out. Is that it? You got to explain.
You guys got what's it called, Venmo or whatever?
Venmo. We'll just Venmo it to you.
All right.
So.
What do I have to explain?
Is that an answer? Is negative 2, 4 a solution?
Yeah.
And why?
There's an X there, there's a Y there, you can plug it in there, see if it works.
Okay, but so you're saying it works. Because you said yeah.
You owe me $1,000.
You owe him $1,000.
I said see if it works.
No, you said yes.
No,
You
I
said
said
yes.
see if it
You
works.
said yes.
Who else heard me say see if it works?
How many? He said yes, didn't he?
I think you figured
Yes.
I think I self-contradicted myself.
You may have. All right, now let me just go.
I'll see you at the deposition.
I think you're upset because of the shirt you're wearing.
Something we know.
I like it.
Look over here on the right. 2x plus 3 equals 7. And I say x equals 2. Is that correct or not correct? Is that the answer or not the answer? Jeff,
How am I supposed to know? I don't really know.
what's 2 times 2?
4,
Plus 3?
7.
So if x equals 2, does that work?
Yeah.
Yeah, so that's the solution. So that's something you know. This is not as familiar, but you got to test it. And you were right, Griffin. You got to test it to see whether it's correct. Where does the 4 go in for?
The Y.
The y. So plug in 4 for the y. Now it says that y value is less than 2 times x. Well, x is negative 2, right? Plus 1. The 4 we can't do anything with. Simplify that on the right-hand side. What is 2 times negative 2 plus 1? 2 times negative 2? Or go ahead, Addie.
Negative 3.
It's negative 3. So is 4 less than negative 3? Oh. Austin? Is 4 less than negative 3?
No.
No. So the final case is it's not a solution. It is not a solution. Okay, so that's all you do is you plug it in. Does it give me a true statement? Does it work? Now here's the thing with inequalities. For that equation over there on the right-hand side, can you give me any other number that works other than 2? No, 2 is the only one. For an inequality, there's more than one answer. There's a bunch, and that's what we're going to have to find. But we're just testing one at a time. Where's the second one at? There it is. All right, so 4, 5. We're plugging that into this inequality. Y is less than x plus 1. All right. Zach, what goes in for y? 5 is less than. Zach, what goes in for x?
4.
So if I do the math now, once I got that written down, what does it leave me? What do I have to combine here on the right-hand side?
4 plus 1.
So what should I write down?
5 is less than 5.
5 is less than 5. All right. Is, Emily, 5 less than 5? It's not. So is this a solution? Nope. You might say it's close, but it's not. It's equal to, but it's not less than. So not a solution. Not a solution. So you got to understand what you're doing. So you're testing it. Okay, does it work? Is that the same one? Do you guys have the same one? Oh, it says less than or equal to. Less than or equal to. So what's the only thing they changed?
Sign.
The sign. So we plug that in. 5 goes in. Whoa. Goes in for y. Is it less than or equal to 4 plus 1? Now I get 5 is less than or equal to 5. Everything else the same. But it says less than or equal to. All right. What do you think there, Lucas? The solution? Yeah, because it's equal to. It hits the equal to part. That's an or. It could be smaller than it or equal to it. So this is a solution. You do the last one. You do the last one. And your final answer is yes, it's a solution or it's not a solution. All right. What do you think back there, Mason?
Like the answer?
Yeah. Is it a solution or not a solution?
Not a solution.
Not a solution. Why not?
Because 3 is not greater than the equal to 6.
But how do you read that symbol right there?
What?
Is that greater than or equal to right here?
No.
That's what?
Less than.
Less than or equal to. So you plug into 3, and I get 3 is less than or equal to. Now read it. 3 is less. Is 3 smaller than 6? Yeah. So it is a solution. So it is a solution. Okay, for that. So we're good. So 3 is less than or equal to 6. All right, so that is just testing. First part you got to do is you got to be able to test it till it's right. Now we're going to get into find all the solutions. Okay, right now that was just one we were testing. All right, down there on the bottom. we are going to graph these. All right, actually, let's go to the back, and then I want to come back to this. Okay. Let's see. All right. Whoa, that's huge. So you got 3 steps, graphing linear inequalities. So if you take a look at that first one down there, it says y is less than or equal to 2x minus 3. We're going to graph that. We're going to find all the answers. We're going to solve the inequality for y. We're going to put it in slope-intercept form if it's not. Step 2, we're going to graph what's called the boundary line. Key thing here, we are going to use a solid line if it is less than or equal to or greater than or equal to. A solid line, okay, like this. We are going to use a dashed line if it is less than or greater than. So we're going to draw it like that, a dashed line. We are going to shade based upon whether it is less than or greater than. It says shade the half plane above the line for y greater than or equal to. Shade the half plane below the line for less than or equal to. And I'll explain why. Check your answer. All right, so let's go to this one here. Let me hand out your protractor. So take a look at that one. If you know how to plot that, you're going to plot the points. You got a slope. You got a y-intercept.
Thank you.
Yep. So you get a nice straight line. Okay, Alex, you remember how to graph?
Yeah.
What's my slope?
2/1.
2/1, good. Is it a positive or negative slope?
Positive.
So it's going uphill, and what's my y-intercept, my b value?
0, -3.
Good. So we start at 0, -3, and I put a dot. And now I got to plug in a slope up 2 to the right 1, up 2 to the right 1. For an inequality, so I'm plot as many as I can here. For an inequality, you either use a solid or dashed line. So what did we just go up above there and say? Should this be a solid line or should it be dashed? Solid. What is the key thing that says solid? It tells me it's solid. Okay, Zach. The equal to part. So it is less than or equal to. Since it has that, it is a solid line. What this does is it divides it into 2 pieces. One half is a solution and one half is not. So I'm going to graph this here, put arrows on it. Okay, now don't write anything else yet. Either the top above it is going to be the whole answer or below it. Do you remember this from before? Last year or the year before? Diana's got like a little bit. Jeff's like, I remember nothing. Okay. Damien, remember anything? Nothing? Okay, Ryan?
No.
No. All right, so I got to make sure I explain this good. So we want all the solutions that work. We want all the solutions. Here's what I'm going to do the first time. I'm going to pick a test point and I'm going to plug it in and see if it works, just like we did before. And you can just pay attention to this part. I'm going to put the point 0, 0. And I'm going to test it. I'm going to plug it in to see if it works. And I'm going to plug it into this one right here. So 0 goes in for y. 0 goes in for x. What am I going to be left with on the other side? What is 2 times 0 minus 3 equal? -3. Is 0 smaller than -3? Oh, it's a big, no. 0 is not. So here's what that means. That means, see that point right there is not a solution, right? So once I find something that's not a solution, it means that the other side of the line, everything will work. So here's what we do. All of these points on the other side are solutions. So you shade, okay, that side of the line. One side of the line will be shaded, and that will be our answer. That means every point over there will work in the inequality, and every point on the other side will not. the reason we do the solid line, that means the points on the line will also work. A dashed line means they won't. All right, look at that shaded region. Give me 1 point in that shaded region, one ordered pair. Yeah.
4 -2.
4, -2. If I test that point into this, y is less than or equal to 2x minus 3, it better work. So I plug in -2 for y, I plug in 4 for x. It says -2 is less than or equal to 8 minus 3, which is 5. Is -2 smaller than 5? Yeah, so it works. Any point you pick in here, 4, 0, 3, 1, 6, 3, they will all work. So you can pick infinite number of points. What about any point on the other side? It won't work. All right, here's the shortcut. I wanted to do this first before I did the shortcut. It is right here in step 3. Once you draw the line, if it is greater than or equal to, you are going to shade where? Above the line. If it is less than or less than or equal, you're going to shade below. So this was a less than or equal to. Which side of the line did we shade? Did we shade above it or below it? We shaded below. So once I did, now I did a test point. You don't have to do a test point every time, but it helps. If you're not sure, you do a test point. All right, let's take a look at the second one. All right, 5x plus 2y is greater than -8. One thing you got to do is you can't say above or below until you get y by itself. And we actually cannot graph it until we get y by itself. So this one we got to do a little bit of work. All right, what do I got to do to get y by itself? Ryan, what do you think?
Multiply 5x on to the -8.
Not multiply it,
Y.
not divide it.
Subtract it.
There we go. Process of elimination. You got to move it over to the other side. So we're going to subtract it. All right, now that gives me 2y is greater than -5x minus 8. 2y. All right, I'm not done yet. I want to just make sure everybody's here. Make sure you're at the same spot. Stay there. Don't get ahead of me. All right. You know what I do, Damien, next to get the y by itself?
You divide everything by 2.
Divide everything by 2. If it gives you a whole number, write it as a whole number. If it gives you a fraction, leave it as a fraction. So that gives me y is greater than -5 over 2. Leave that like that, x, and then -8 divided by 2 is -4. So now we got it in a nice form. All right, the two key things that are a little bit different that I want to hit now, we're going to talk about it now, and then we're going to graph it. Since it's just greater than, is it going to be a solid or dashed line? Let's answer that first. Solid or dashed? And do we know how to figure that out? Addie, do you know? Austin.
That's going to be dash.
All right, yes, it's going to be dashed. All right, now, here's where we find out. This goes to step 2. If you look up at step 2, the boundary line, this is what we're going to graph. Solid if it has an equal to part, dash if it has just greater than or less than. So that's going to be dashed. Will we shade above or below? Dash line, so I'm going to put this down first. And above or below, Austin?
Above.
Above because it's greater than. Just think greater than. You got two things. Is it above or below? Greater than is going to be associated with the word above. So we're going to shade above. Now I got to graph the line. My slope, -5 over 2, so it's going downhill. My y-intercept is 0, -4. So go to 0, -4 and put a dot. I'm going to pause here while you guys, at least if you're behind, you get caught up. But put that dot at 0, -4. And if you're really confident, go ahead and plot the points. Make sure they're going downhill. Make sure that you gotta draw that line very clear. Okay. All right, we wanted to go downhill, right? Okay, so you're gonna go up and to the left. Okay. Right, I'll do the left. All right, I'll do it here in a second. What's that? This is your one for the week. All right. One for the week. Mason and Chris.
Mason,
All right.
you're done.
Negative slope. We go up 1, 2, 3, 4, 5, and to the left 2. Nope. Yep, that would give me downhill. Sorry. 1, 2, 3, 4, 5, and to the left 2. So I got room to put one below it. Okay. What type of line? What type of line? We already talked about it. Dashed. So you got to draw it in. It clearly has to be dashed. So there's your line.
Do you guys know what that means as far as the answer goes? Are lines on, or points on that line gonna be a solution if it's a dash line? No, solid line only, right?
Right. So that means those points. There's an infinite number of points on that line. They will not work because they will not make it equal to. Now, a shade above or below that line, Jeff?
4, 4.
No, just do we shade above or below? I'm sorry.
Below. Above.
Yeah, good way to fix that. Shade above. Why does it shade above? You got to know because greater than. We want all the numbers greater than. Y values that are greater than. Now, where's above at? Sometimes it's not obvious. If you put a point on a here and I just draw straight up, that just, I mean, it should be clear in the most point, but sometimes if it's not obvious, just draw straight up. I'm going to take that and we're going to shade in all of these values here. All of them are going to be part of my answer. So I can pick any of them. Any point in there will work. Any point on the other side will not work. That's how you test it. So if you really want to double check, pick a point or two, plug it in, make sure it works. And all right. Now this one doesn't look great because everything, we're not used to this. We're not used to this. What's our goal? And there's probably a couple ways you could do this. Some of you may see one way or another. What do I got to get by itself? Why? What do you think? What would be your plan?
Add one.
Okay, you can add y. This might be the easiest, but not the only way. We're going to have to do something first. So I'm going to add y. I'm going to add y. That'll give me 4x plus 2 is less than or equal to y. Every problem we write, how's it always written? What's on the first thing on the left-hand side? So how can I switch that? How would I rewrite it so the y comes first? What do you think, Jeff? How would I flip that order? Lucas?
Y is greater than 4x plus 2.
Greater than or
Equal to.
equal to 4x plus 2. Yes, you do that. You would have to, since we're switching that order, it has to be pointing away from the y. So you'd have to make it y is greater than or equal to 4x plus 2. All right, make sure you got that down. Then you got to identify, is it going to be dashed or solid? Is it going to shade above or below? Is it going to be dashed or solid? Shade above or below? And what determines that? Okay. One, dashed or solid? What do you think? Okay, what's telling us that you are correct? What part tells me that? What do you think? Or was that just a really good guess? The sign says it has an equal to part. All right, shade above or below? Reese, what do you think?
Below.
What's telling you that?
The less than or the equal to thing.
Not the equal to thing. It's either less than or greater than. How do you read that? Is that less than or greater than? Greater than. Greater than is not going to be below. Greater than is going to be above. So we want to shade above when we're done. All right, now we want to graph it. Let's just go over here and plot this. It hits at 2 is my y-intercept. Positive 4. So you go up 1, 2, 3, 4 over 1. Over 1. Down 4. Over 1. Okay, solid line, shade above it. So once you got that, solid line, shade above. Okay, and so I'm going to connect here. Oh, let's see. And now when you shade above, okay, so this is almost vertical. Above it, okay, it was actually going to be kind of here on that left-hand side. So you got to think where that above part is. And this is going to be above it. If you put a point, your pencil on the line, and you go straight up, that'll tell you where to shade. So all those are answers. All those are answers. Good. Is good? All right. Now, that very last thing on the bottom, we're going backwards. They give you the graph, and they're saying, hey, what's the inequality that matches that? And I'll start it for you. It starts with a Y. Is it less than or equal to, greater than or equal to, and what's the equation? Interesting. Yeah.
This is greater than.
Good. It's shaded above the line, and it's a dashed line, so it's greater than. That's good. Now, greater than what? Here's what we need to do. We need to come up with the equation of this line. So we need to know its y-intercept, and we need to know its slope. Look careful. We want to find another point where it hits exactly at a corner. That one's really close, but it's not. It doesn't go through that point. It goes through here. This right here tells me it's rise and run. It's a positive slope because it's going uphill. And what's its rise? It is 3. What's its run? 1, 2, 3, 4. All right, so what would be my final answer for this one? Y is greater than what? Okay, 8, you know?
3 over 4 plus 2.
3 over 4, don't forget the x. Not plus 2, double check. That's not plus 2, it's plus what?
1.
Plus 1. This is what it would be. Y is greater than 3/4 x plus 1. My slope is 3/4 plus 1. Got it? Plus 1.
Where'd you get the 1 from?
That is right here. That is the y-intercept. Wherever it hits the y-axis is what that plus 1 is. Where'd the 3/4 come from?
The rise and run.
Rise and run. So those are the two things we got to get. The rise and run and the y-intercept. So take a look at B. Do B on your own. See what you can come up with. They throw a.
I don't know why I do that.
Yeah, all right. This is -5. Let's do that. That's -5.
So now your slope's all jacked.
Yeah.
Well, the intercepts are what? What is that?
That's -10.
-10, 0.
So it's not too bad once we get it. All right. Start out with Y. Less than or equal to, greater than or equal to. So it's a solid line, right? Shaded below. What does that tell us for our sign? Okay. What? Zach?
Less than equal to.
Less than or equal to. Zach, do you know how to give me the equation? Hey, how about I do this first? What's my rise, Zach?
1,
If that's 0, -5.
4.
Not 4, it would be 4 if it would hit right here. So it hits all the way at 5. So to go up from here to there, that would be actually a distance of 5. What's my run? Hold on. Austin, you know what my run is?
6.
All right, it's 6 here on, but what's the actual x value right there?
-10.
-10. So it actually goes 10. So that would be 10. Since it goes downhill, my final slope would be -5/10, which we'll reduce in a second. Put an x there, and then what's my y-intercept? Where's it hit the y-axis at? Negative what?
5.
5. What is -5/10 reduced to? -1/2. So you want to make that as your answer. Okay, so that's a little more involved. That was a little more involved. Okay, 4. Homework. If you don't, you need to do this on graph paper. If you don't have graph paper, I will give you a piece, and you need to make sure you start bringing some
Somebody need a graph paper?
next couple of days. I'll collect your protractors. And where are you gonna submit?
Graph paper, keep your hand up.
And we gotta submit homework. Everybody know, it's a great show.
Graph paper, guys. Graph paper.
Did you see any of the things about how like Seinfeld, some of the episodes would be based upon the pandemic? I don't know how to find that.
Funny?
Yeah, I'll have to check it out. It's like Kramer would be, or like Elaine would be boarding tests. Boarding tests.
Oh, yeah.
Thank you.
I think they lost the purpose just for the draft pick.
Yeah. Who left their Canada Dry ginger ale?
Is it open?
It's almost empty.